In this example, we're going to be doing a word problem, and we have some data, and we're going to try and answer some questions related to that. So it says a table and a graph below show how the incidence of Down syndrome in newborn infants increases with the age of a mother. The data can be modeled by the exponential function here. All right, so here's your exponential, here's your initial value, and then you have a growth rate of about 27%. So where A is the age of the mother in years, and P of A is the incident, the number of Down syndrome children per total births. Right, so here's our data. So at age 30, 1 in 900 versus age 49, 1 in 12. Right, so according to the model, at what age is the incidence of the Down syndrome children equal to 0.01? Right, so how do we do that? We can kind of look at the data, but to be accurate, we're going to use some pre-calc college algebra for this. And so we're going to take our equation. We're going to set it equal to whatever percent that we're looking for. So 1 over 1613000 2733 raised to the A equals 0.01. So I'm going to solve that. So if I'm going to solve that, I'm going to multiply this piece over to the other side. So here's our kind of cutting into our space here. 1613000 1613000. So to clear my fraction, I'm going to multiply it over to the other side, and I'm looking at 1.2733 to the A equals whatever that value is. So I throw it into the calculator, and that's going to get me a 16130, and then which basically I'm just moving the decimal place back 2 spots, and then I'm going to log both sides. Right, so I'm going to natural log both sides. Right, and the reason I do that is because logs don't keep exponents, so that A is going to come off of that. So the natural log of 1.2733 equals the natural log of 16,130. And then I can isolate A by dividing over this natural log. 1.2733 divided by natural log 1.2733. And my A value, which is the age of the adult, is about 40.1 years old. So if I look through this, that's kind of where we hit. Somewhere in between that range is where we're going to hit our 0.01. Okay, so that does agree with our table. All right, so we want to compute the slope of A. So they're not asking for a particular age. That's going to come here. So what that is talking about is finding the slope, the rate of change at a particular age. Right? It's growing exponentially, but what's the rate at which it's growing at every single year? So as you age, your rate is increasing, right? It's not growing linearly. So this is essentially us finding the slope equation. So our slope equation is us doing the derivative of this. Okay, so to do the derivative of this, I'll still have that 1 over 1613000. And then I'm going to multiply. So the derivative of an exponential is, just to kind of refresh, we're going to be doing the derivative of an exponential, and it's going to turn to this. So it's itself times the natural log of the base times the derivative of the exponent. So we have itself, which is 1.2733 to the A times the natural log of the base, 1.2733 times the derivative of the exponential, which is 1. All right, so if I push all of that together, I put all that together, really I'm just going to take this fraction times this natural log times 1, which isn't really going to do anything, and I'll get my slope equation to be, if I multiply the natural log of that times that, we're going to get a really, really small decimal. So 0.00000, so 6 of them, 1, 4, 9, 8, and then 1.2733 to the power of a. So that is our slope equation. That's going to be our rate of change depending upon the age. And again, from 35, so we're going to be finding what is the rate of change at 35, age 35 versus age 46. So at age 46, it's much steeper. So your rate of change is increasing quite a bit more than at age 35. All right, so that's really all we're looking to do. So what is the slope at age 35? And that is us taking this, right? 6 of these. 1, 4, 9, 8 times 1.2733 raised to the 35th power. So I'll plug that into the calculator, and that is a rate of change of 0.000705. Or if you make that into a fraction, I'll basically kind of make that into a fraction. That's 7 tenths, hundredths, thousandths, 10,000. So it's or 7 10,000. So that's the rate of change. So that's kind of the slope at that point. Versus when you do at 46, you're looking at the exact same thing. We're just plugging in a 46 versus 35. So 1, 2, 3, 4, 5, 6, 1, 4, 9, 8, 1.2733 raised to the 46th. And if you plug that in, you're getting about 0.01. So that is a very, very big difference because that is 1/100th, right? So the slope of that is drastically different compared to the slope of that. And so you can see that visually that you got yourself an exponential, and that's what's happening. All right, so that was a word problem that involved, the math didn't change. It just was a word problem. So there was some context associated with our answers.